Electric arc welding. It's so conventional in the mechanical construction industry that it's easy to forget how hazardous it can be when it's not done safely.
When you really think about it, electric arc welding can result in serious burns, severe eye damage, respiratory and other health problems, fire, and probably the biggest hazard of all, electrical shock.
Back in September, one of our fitters in Kansas was following his normal work routine, preparing to weld the backside of a 90-degree elbow. He was using a high-quality AC/DC stick welding machine made by a leading manufacturer. The work cable was clamped to a structural steel beam about 20 yards away from the elbow. Our fitter was kneeling on two insulated pipes that were also wrapped in sheet metal. The two sheet metal-covered pipes were supported by the same structural steel beam that the work cable was clamped to. With his free hand resting on the pipe he was welding, he struck an arc and felt the surge of electricity flow through his body. It was a full 10 seconds before he could let go. The foreman called 911 and rushed him to the hospital.
Miraculously, after the bleeding was stopped, he was sent home from the hospital with just a massive headache. He was unbelievably lucky. Electrocution is the fourth leading cause of death in the construction industry, and too many other workers get badly shocked or suffer terrible burns from the heat generated by electric arc welding current. In this case, it was the perfect storm. A number of elements came together simultaneously, creating a life-threatening hazard. Let's talk about what we learned from our fitter's experience so it doesn't happen again. Most of the electrical shock incidents that happen during electric arc welding operations occur when the welder somehow becomes the current's path from the electrode circuit to the work circuit.
Electricity travels in a circuit. The circuit is completed when the welder strikes an arc with his electrode. Typically, the current flows from the welding machine through the electrode holder cable, through the electrode, through the work itself, and then through the work cable back to the welding machine.
Our fitter unwittingly became part of the circuit for 4 key reasons.
First, his work cable was not clamped to the pipe he was welding on, but to a structural steel beam. Second, that steel beam was 60 feet away from the elbow he was welding to the pipe. The combination of these first two elements made for a vulnerable circuit. Third, he was kneeling on sheet metal covered pipe that was in direct contact with that same steel beam. Fourth, it was brutally hot that day and he was sweating profusely. Even though he was wearing brand new welding gloves, they were soaked through with sweat, and so were his pants. Typical stick welding machines use somewhere between 10 and 600 amps of current, but it only takes about 70 to 100 milliamps to kill a person. A milliamp is 1/1000th of a single amp. It just doesn't take much current to deliver a powerful shock and not much more to kill a person.
Electricity will always travel the path of least resistance. That means it travels through the most conductive material it can find at the time, even if that material is the human body. Our fitter became part of the easiest path to completing the welding circuit as soon as he struck the arc.
The current passed from the electrode to the pipe, through the wet glove into his hand, through his body and out the wet pant legs, and into the sheet metal cover. So let's talk about how to avoid becoming part of a welding circuit or part of the easiest path for current traveling to ground. It's pretty common in our industry to clamp the work cable to a structural steel beam, but the welding machine manufacturers direct us to clamp the work cable directly to the work itself and as close to the weld as practical to ensure a complete and strong circuit. It's simply the best safe work practice.
Even though the work pipe seemed to be electrically connected to the steel beam, That current path was much weaker than the current path through our fitter's body.
If our fitter had clamped his work cable directly to the pipe and close to the elbow he was welding, the current would never have had the opportunity to travel through his body. So from this point forward, always clamp the work cable directly to the work. When the pipe or other work won't receive a standard ground clamp, use a magnetic ground clamp and attach it as close to the weld as practical.
Just as electrical wires are insulated, you need to keep yourself insulated from the current. If our fitter, even with his damp clothing, had insulated himself from the sheet metal, he wouldn't have become part of the circuit. Always insulate yourself from the electrode circuit, from the work itself, and from ground.
Avoid electric arc welding in wet environments. If you have to work in an environment that's a little damp, or if you're sweating, use dry rubber welding mats for insulation. Check to ensure that all parts of the stinger leads are in good condition. And don't ever use damaged leads or other damaged welding equipment. Follow your company's procedure for taking defective equipment out of service immediately and get that equipment replaced. Be extra careful when changing electrodes and never use your bare hands. Arrange the cables so they're protected from hot slag and sparks. Cable insulation can melt, exposing electrical wires if they're not properly protected.
Electric arc welders endure more than their fair share of burns, too. There are two things you should do to prevent burns.
First, perform a pre-task safety plan to eliminate or isolate yourself from burn hazards. And second, use the right personal protective equipment. Wear leather boots that fit correctly and cover your ankles, and long pants with no cuffs. That way you minimize the risk of getting burned by hot slag trapped in your clothing. As extra protection from sparks and slag, many fitters and plumbers wear flame-resistant leggings or complete coveralls that are specifically designed for hot work. Always wear long-sleeve, untreated natural fiber shirts without pockets or cuffs. And don't forget to check the fabric.
Most synthetics, such as polyester, nylon, and acrylic, burn and melt easily. So make sure you don't wear anything to the job site that's made out of synthetic materials.
Wear natural fabrics like cotton or wool. They'll burn too, but they won't melt. Flame-resistant fabrics designed specifically for hot work operations are the best choice. And of course, heavy-duty welding gloves protect your hands from burns and help protect you from electrical shock, but only when they're dry and in good condition. Now let's take a look at your eye protection. You need to use different shades of filter plates or lenses, depending on the size of the electrode and the amount of current that will be generated from the work. Make sure you're wearing the proper shade filter plate or lenses before you look at an arc, even for an instant. The minimum shade you'll need for electric arc welding is a number 10, but sometimes you'll need even more protection, like a 12 or a 14. Just be sure to follow the welding machine manufacturer's recommendations or check with your supervisor. You also need to wear safety glasses that wrap around the sides of your eyes underneath your helmet to protect against sparks and slag. It's especially important to have your eyes protected when you lift the face shield, like when you're looking for something, or wire brushing your weld, or just inspecting your work. And don't forget about everyone else's eyes, too. Use welding shields or screens so others in the work area won't experience welder's flash.
And one more thing. Some welders are notorious for removing their hard hats to accommodate their welding helmets, but head protection is required 100% of the time on most jobs.
With this type of rig, you can keep your head and face protected with a single piece of equipment, keeping everybody happy. Now let's talk about ways you can deal with respiratory hazards. Metals that are heated to the melting point can generate noxious fumes.
Metal fumes, like those from hexavalent chromium or from lead, zinc, and manganese, can cause serious health problems over a period of time if they're inhaled in large enough concentrations. Safe work practices and good ventilation are usually all you need for adequate protection.
Always situate your body so you're not inhaling fumes. Position your welding helmet so the fumes can't rise up underneath it. Also, make sure that your work area is well ventilated. If you don't have adequate local exhaust ventilation where you're working, you can use a point-of-operation ventilation system like this smoke eater, or an industrial-strength fan to blow the fumes away from your breathing zone. But there may be times when safe work practices and ventilation alone don't provide adequate protection. When that's the case, you may also need an air purifying respirator. Your supervisor will let you know if a respirator is needed and ensure that you're trained, fit-tested, and medically qualified to use it properly.
Electric arc welding generates potential ignition sources, which means fires are a potential hazard too.
When metal gets hot enough, there's always danger of sparks or slag landing in a pile of sawdust, dust collected on top of sheet metal ducts, rags, or other flammable materials. Pretty soon it can start to smolder, and if conditions are right, it can turn into a raging fire. Keep your work area clean. Make sure it's clear of any combustible materials like paper, trash, oily rags, and grease. Don't hesitate to grab a broom and clear yourself some room to work. Protect the floor and wall penetrations and keep at least one Class ABC fire extinguisher nearby. You never know when it might come in handy. Fires often smolder for a while before they burst into flames, so be sure to check the facility's and your own company's requirements for fire watch. At a minimum, make sure there's nothing smoldering in your work area for at least 30 minutes after you stop welding for the day.
Electric arc welding can be done safely and effectively if you pay close attention to the most common hazards associated with it, and pay extra special attention to preventing electrical shock hazards.
Carefully inspect all of the welding equipment, especially the stinger leads and the electrode holder, and take any defective equipment out of service immediately. Clamp your work cable directly to the work. Make sure you attach the work cable clamp as close to the weld as practical. Don't weld in wet environments. Wear all of the proper personal protective equipment, including welding gloves. And if your gloves or clothes get wet from sweat or from any other source, insulate yourself from the work with dry rubber welding mats.
No one can count on being as lucky as our fitter who survived the electrical shock. But now that you know what he learned that day, you can avoid becoming part of a circuit or an easy path to ground, and your own electric arc welding operations will be much safer.